Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. And this group, we're going to be going over problems 29 to 33 of the Algebra 1 New York Regents exam for January 2016. All right, let's take a look at number 29. It reads, the cost of belonging to a gym can be modeled by the function C of m equals 50m plus 7950, where C of m is the total cost of m months of membership. State the meaning of the slope and the y-intercept of this function with respect to the cost associated with the gym membership. Okay, so slope and intercept. What equation relates to slope and y-intercept? It is a slope-intercept form of the equation of a line. Okay, so there goes the slope-intercept form when we color code it so that we can extract or focus on relevant components. Y equals mx plus b. This is called the slope-intercept form because it easily tells you what the slope and intercepts are just by looking at the function. Now, the question is, what is the meaning of the slope, the slope and the y-intercept in this model that's provided here? So we're focusing on the slope and the y-intercept. Now, one thing I would like you to remember is that the slope basically represents the growth rate, okay? By how much is it growing every single month? That's the growth rate, okay? And then think about your y-intercept as your starting amount, okay? So your starting value of the function, okay? Now, in the context of this problem, what is the growth amount? Basically, what do you get to pay every single month? And what do you start with? That's what we are asked to determine here, okay? So what I'm going to do is I'm going to rewrite this function. Just write it down here. So we have C of m equals 50 is the coefficient of the dependent variable m. Remember, m is dependent on the independent variable for this equation. In this equation, the independent variable is m, okay? So 50m plus 7950. All right, so based on how I wrote it, can you see what the slope and the y-intercepts are? The slope is 50. And the y-intercept is 7950, okay? So this is a slope right here. And our y-intercept, you can click, is a constant, okay? The constant is your y-intercept. And the number that's next to the independent variable is your slope, all right? So what do each one mean? Well, we have two. If you think about the gym membership fee structure, I don't know if any of you have joined the gym, have a gym membership, but anytime you want to join a gym, most of the times there are two fees. You have your monthly dues. You have your monthly dues. That's the amount of money you pay every single month. And then you also have your initiation fee or a deposit. Okay, so let me call it initiation fee. Okay, the initiation fee is always one time. It doesn't matter how many months you attend the gym, you just pay that initiation fee once, and then after that, you start to pay your monthly dues. All right, so the question is, if you look at this function right here, with a growth of 50 and a starting value of 7950, can you identify which value is the monthly dues and which is the one-time initiation fee that's independent of how many months you attend the gym? Well, let's write it out. The slope, in this case, the slope, coefficient of the independent variable, which is equal to 50, guess what? This is the monthly dues, okay? Represents the monthly dues because it's dependent on the number of months that you attend the gym. All right. And then the y-intercept and the y-intercept. The y-intercept in this case is that 7950. This is the it represents the initiation, the one-time initiation fee or deposit. Okay, one-time initiation fee for the membership. Okay, so that's basically what the different components of this linear equation represent. All right, let's take a look at question number 30. It says, a statistics class surveyed some students during one lunch period to obtain opinions about television programming preferences. The results of the survey are summarized in the table below. So we have the programming preferences illustrated here. Based on the sample question, predict how many of the school's 351 males will prefer comedy. Justify your answer. One thing you want to note is that concerning ratio and prediction, if you carry out a survey with a sample population and a certain ratio manifests itself, you can use that ratio to make predictions as to the patterns that will emerge in a larger population. Okay, so in this situation here, we have some students that were surveyed, and we're going to use the results to make generalizations as to what's going to happen to the entire school. Okay, we're focusing mainly on the males here. All right, so the formula we're going to be using is the ratio. We're focusing on comedy preferences. Okay, so the ratio, let's write this down, formula. So the ratio of people that prefer comedy is simply the number of people that prefer comedy divided by the total number of people. Total number of people. Okay, so that's the formula we're going to be using to guide our problem solving process. We're going to be using this equation twice. We're going to use the results from the first equation to solve the second one. Okay, so keeping this formula in mind, let's take a look at the experiment. We had a sample population, which is just some students that the stats class interviewed during lunch. Okay, so let's formulate an equation with that information. So for the sample, how many male students were interviewed? So we want to see, we're focusing just on males, okay? So for the sample, the number that preferred comedy is basically 70, okay? Just males. And then the total number of males for the sample, total males is 70 plus 35, which is 105. 105 males. Okay. So what's the ratio of males that prefer comedy in this sample population here? What's the ratio that prefer comedy? So we're going to use our formula. So the ratio that prefer comedy is basically the number of males that prefer comedy, which is 70 divided by the total number of males, 70 divided by 105. Okay, let's go ahead and carry out that division. So we have 70 divided by 105, 0.666 repeating. Let's convert this to fraction, 2/3. Okay, so 2/3 of the sample population of males prefer comedy. Okay, So now what we're going to do is we're going to apply this ratio to the entire school. Okay, we're just making a prediction here. It doesn't have to be correct, but it just gives us a general idea. So entire school. Remember, our focus is just on the males, okay? So the same formula applies here. So for the entire school, the number of males that prefer comedy is what? For the entire school, the number of males that prefer comedy is an unknown. That is what we're looking for, okay? How many males are there in the entire school? 351, okay? And what, using our little sample activity here by the stat students, what ratio prefer comedy? So we are just making a prediction here. The prediction is that the ratio of males that will prefer comedy is going to be the same as the sample population, which is 2/3. Okay, so that's what we got here. In the sample population, 2/3 of the males preferred comedy, so we want to make a prediction that 2/3 of the entire male population of the school will prefer comedy. Okay, so using the formula that we have over here, ratio that prefer comedy is equal to number divided by total population. We're going to have the ratio 2/3 is equal to the number of males that prefer comedy. Is this right? Number of comedy divided by the total number of males in the school. Okay, to get this by itself, number that prefer comedy multiplied with size by 351. So what's happening here is we're taking 2/3 of the entire male population of the school. Okay, and that should give us the predicted amount of the male students in the school that prefer comedy. Okay, so number prefer comedy is going to be 2/3 times the population of males in the school, 351, 234. Okay, so let's go ahead and write our justification just to state what our argument is. So justification. Since 2/3 of the males of the sample population prefer comedy, predicting with that ratio on the entire male population of the school yields, what does it yield? It yields 2/3 of 351, which is equal to 234. So all we are doing is we're just using the ratio that we got from a sample population and making a prediction by applying the same ratio to the entire population of males in the school, and that's what our expected figure should be. All right, let's take a look at problem 31. It says, given that A is greater than B, solve X in terms of A and B. So we have to solve this inequality right here. So we have B times the quantity X minus 3 is greater than or equal to AX plus 7B. Now, one reminder that you want to keep in mind when solving inequalities is that anytime you divide by a negative number, you have to reverse the orientation of your inequality symbol. Okay, so let's keep that in mind. Anytime whatever we have to divide by here, we have to check to make sure that it is positive. If it's not positive, then we have to reverse the direction of our inequality to compensate for that division. Okay, All right, so the goal here is to solve for x, so we want to get x by itself. What we'll notice is that x is all over the place, so we want to collect all the terms with x's. This x is grouped with this 3, and b is being multiplied by them. So in order to isolate it, we have to distribute this b to both terms here, so we can have them separated. Bx minus 3b is greater than or equal to ax plus 7b. Okay, so I want to collect all the terms with the a's on the left side. So subtract ax from both sides. And then that leaves us with bx minus ax minus 3b is greater than or equal to 7b. Now the term without the x needs to be moved over to the right. So we're going to add 3b to both sides. And that yields bx minus ax is greater than or equal to 10b. Now the 7 plus 3 is 10. X is common to these two terms, so we can factor out x. And we're left with b minus a, and that's greater than or equal to 10b. Now, in order to get x isolated, we have to divide both sides by b minus a. So now we are dividing, so we got to ask ourselves, is b minus a positive or negative? In the initial problem, we're told that a is greater than b. If you subtract a bigger number from a smaller number, what will you get? You will get a negative number. Okay, so let's write a real quick note here. Since a is greater than b, then b minus a is less than 0. It's negative. So what are we doing here in this step? We're dividing by a negative number. Okay. So what do we do anytime we're dividing by a negative number? If you're dividing by a negative number, you have to reverse the orientation of your inequality. So we have x is less than or equal to 10b divided by b minus a because we divided by a negative number. And that, ladies and gentlemen, is our final result. All right, let's take a look at number 32. It says Jacob and Jessica are studying the spread of dandelions. Jacob discovers that the growth over t weeks can be defined by the function f of t equals 8 times 2 to the t. And Jessica finds out the growth of the function over time. T weeks is g of t equals 2 to the t plus 3. Question, calculate the number of dandelions that Jacob and Jessica will each have after 5 weeks. Okay? All right, so let's go ahead and do that. Let's start with Jacob. So Jacob's function is f of t equals 8 times 2 to the t. So the independent variable here is t. What we're going to be using to calculate our output, what we're going to be plugging in is the t value, okay, to generate the output. So t, as indicated here, is in weeks. So for 5 weeks, we basically have t is equal to 5. Okay, so for Jacob, to calculate the number of dandelions he'll have in 5 weeks, we're computing f of 5. Basically replacing all the t's in Jacob's function with 5. So 8 times 2 to the what? To the 5th power. All right, you can do this with your calculator. Let's do this by hand. So you have, well, let me show you how to do this with your calculator. So if you want to do this with your calculator, you simply go 8 times 2 and then caret 5. Okay, and the answer is 256. So 8 times 2 to the 5th, or you can write it as 8 times 2 to the 5th is 32. And then when you multiply it together, you end up with 256. All right, so that's the number of dandelions that Jacob will have in after 5 weeks. Okay, how about Jessica? Jessica has her own exponential function here. versus g of t equals 2 to the t plus 3. So when t is equal to 5, how many dandelions will Jessica have? This can be determined by substituting 5 for t in her function. Okay, so we have 2 to the 5 plus t. I'm sorry, 5 plus 3 because t is 5. And then this becomes 2 to the 8th power. And let's see what that is equal to. 2 caret 8 is 256. 256 is the amount of dandelions that Jessica will have. Okay, let's take a look at the next question. Still part of problem number 32. That says, based on the growth from both functions, explain the relationship between f of t and g of t. Okay, so we have these two functions. Let's go ahead and write them down. F of t is 8 times 2 raised to the t power. That's for Jacob. And g of t is 2 raised to the t plus 3. Now, one thing you notice is that these two functions are written in different formats. If we express them in the same format, then we will be able to carry a much more accurate, do a much more accurate comparison as to which one is going faster, for example. Okay, so what we're going to do is we're going to rewrite the functions in the standard exponential function format. Okay, we write the functions in f of x equals a times b to the x format where applicable. Okay, so we are going to bring both of them into the same format so we can make a much more accurate comparison. Now, the nice thing is that Jacob's function is already in that format. We have the constant times the exponential term 2 to the t. So let's leave this alone. Now let's focus our attention on Jessica's function. Jessica's function is not in that format yet. So let's do some work there. So Jessica, we have g of t equals 2 to the t plus 3. So this one we have to rewrite. All right, so we're going to be using properties of exponents here. So we have g of t equals 2 to the t plus 3. If you think about the product property of exponents, when you multiply two exponents of the same base, so let's say we have a to the x times a to the y, what do? You add the powers, right? So whenever I multiply exponents of the same base, you add the powers. Whenever you have the sum of powers of an exponent with a base, you can express it as the base raised to the first power times the base raised to the second power. Okay, so 2 to the t plus 3 can be written as 2 to these addends multiplied by each other. Okay, so 2 to the t plus 3 is the same thing as 2 to the t times 2 to the 3. Because since you're adding powers is the same thing as multiplying two exponents with the same base, and their powers equal the addends, the terms that you're adding with each other as illustrated here. Okay, so in this product property of exponents, you can go in this direction, or you can go in the reverse direction as we just did. Okay, so this is basically the decomposition of the product property of exponents. Let's simplify further. So we have g of t is equal to 2 to the t, 2 to the third power is 8. Okay, now since multiplication commutes, we can rewrite g of t as 8 times 2 to the t. Now look at f of t and look at g of t. What do you notice? They are identical. Okay, so the relationship between, let's write it down, the relationship between f of t and g of t is that they are identical, okay? All right, let's take a look at the first part of question 33. It says, let h of t equals negative 16t squared plus 64t plus 80 represent the height of an object above the ground after t seconds. Determine the number of seconds it takes to achieve its maximum height. Justify your answer. Okay, so the object basically attains its maximum height at the x-coordinate of the vertex. Okay, that's the time that the object attains its maximum height. So let's go ahead and write it down. The object attains its maximum height at the x-coordinate of the vertex. Okay? The vertex of the graph of the function. Okay? So that's what we are going to be looking for. So how do you compute the how do you determine or calculate the vertex of this function right here? There are different ways you can do it. You can complete the square, you could use your graphing calculator, or you can use a formula. I'm going to be using the formula, okay? So Tmax, basically the time that it achieves its maximum height is equal to negative b over 2a. Okay, so this is what we're going to be using here. So we have the function h of t equals negative 16t squared plus 64t plus 80. So let's see, what is A? A is negative 16, B is 64, and H is 80. Okay, so just one side note. So this is the formula we're using, where the vertex formula is basically negative b over 2a times h evaluated at negative b over 2a. So this is how you calculate the vertex, okay? So the x coordinate of the vertex tells you the time, and the y coordinate of the vertex tells you the actual maximum height that the object attains, all right? So let's go ahead and focus on what we're looking for, which is the time, the x coordinate. So Tmax is going to be negative 64 divided by 2a, 2 times negative 16. All right, so we have negative 64 divided by negative 32, and then you have 2 seconds. All right, so the object attains its maximum height at t equals 2 seconds. The x-coordinate of the vertex of the related parabola, okay, of the related parabola. There's also a maximum function in your calculator that you can use to carry out this calculation, okay? Okay, let's take a look at the second part of question 33. It says, state the time interval in seconds during which the height of the object decreases. Explain your reasoning. Okay, so the height of the object decreases right from when it gets to its maximum height all the way to the time that it hits the ground. Okay, so let me just illustrate this for you with a sketch. So what happens is that the object is tossed up, it goes all the way up, hits its maximum height, and then comes down. Okay. All right, so the height of the object decreases right from the time it hits its maximum height. So this right here, from this time, guess what this is called? This is called Tmax, okay? From Tmax all the way till the point where it hits the ground, okay? So from here all the way to when it hits the ground. When it hits the ground, here at this point you have the height is equal to 0, because when you're on the ground, you're 0 distance away from the ground. Okay, so this is the interval that we're looking for, okay, where the height is decreasing. So it turns out that we already know some information. From the previous problem, we figured out that the time that it attains its maximum height was 2 seconds. So we know that Tmax is 2. So from 2 to a later time, that's when the height, there's an interval where the object is decreasing, okay? So let's write down some justifications or our reasoning as to what we're about to do. So the height of the object decreases from when it attains its maximum height, its max height. We already know what that is. T equals 2 seconds until it hits the ground. Hits the ground. Okay? It hits the ground when h of t is equal to 0. Okay? So the question is, when does the object hit the ground? It hits the ground when h of t is equal to 0. So all we just have to do is solve a quadratic equation, and that will give us the upper bound of the interval on which this object is decreasing in height. Okay? So we already know what h of t is. It's the projectile motion function of this particle, of this object. All we're just going to do is set it equal to 0 and solve. Okay? So let's write down what we're about to do. We're going to solve h of t equals 0. All right, so negative 16t squared plus 64t plus 80, say that equals to 0. Now, I noticed that 16 goes into all three terms, so I can actually reduce this equation by dividing by negative 16. If at all possible, please try and make your a positive, okay? It really saves you from dealing with headaches down the line when you're factoring. All right, so try and make a positive wherever when you're factoring, when you're solving quadratic equations by factoring. Even if you're using the quadratic formula, try and get rid of the negativity of a just to keep things looking good. Okay, so when I divide through, I have t squared. 64 divided by 16 is negative 4. 80 divided by 16 minus 5 equals 0. Great, this looks much better. Okay, so let's go ahead and solve that. So we're going to use the x gain here. Let's hope that this is factorable. If not, we'll have to resort to the use of the quadratic formula. Okay, so AC is negative 5, B is negative 4. What two numbers multiply to give you the top and add to give you the bottom? Let's see, 5 and 1. Negate 1 so that the sum is negative. Wait a minute, no. In order for the sum to be negative, the bigger of the two has to be negative. So make 5 negative. All right, like that. Bam. Okay, so times this, you get the top, add it, you get the bottom. Good. So the factored form is going to be t minus 5 times t plus 1 equals 0. So if you use the zero product property, set both of them equal to 0. First one, you add 5 to both sides, and then you end up with t equals 5. And then the second one, you subtract 1 from both sides, you end up with t equals -1. Well, this is not an answer since time cannot be negative, okay? So this doesn't make any sense. It's just t equals 5, okay? So the object hits the ground, hits the ground at t equals 5 seconds. Now, for problems like this, when you're asked to state your reasoning, you want to write down your thought process, right, as much as possible, so your grader knows that you understand what's going on. Okay, so the height of the object, object decreases from uh, t equals 2 to t equals 5. Okay, we were asked to write it down as an interval. So in interval form, you can write it goes from 2 is less than t and t is less than 5, or you can write parenthesis 2 from 2 to 5. Okay, so that's the interval where the height of the object is decreasing. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Your positive feedback is very important to us. Don't forget to subscribe for updates to the remainder of this review series. If you have any questions, just ask your question in the comment section below and we'll be glad to support you. More clips can be found on math.serve.com under test prep. Thanks again for watching and have a wonderful day.